Hello, and welcome to a concise explanation of the mole. Not the kind of mole that you may be thinking of, a little nuisance that runs around in the ground in your mother's garden. No, not that kind of mole. The word mole is very much like the word dozen, except the word dozen refers to a certain quantity 12. The mole refers to a certain quantity 602 sextillion 213 quintillion 670 uh, quadrillion of something. Now, you might buy corn by the roadside in dozens. You would never want to buy corn by the mole. That would be a lot. If you had a mole of popcorn kernels, you could cover the United States in a pile that was 310 miles tall of popcorn kernels. This is a huge number. In scientific notation, which is always nice and easy to use, compared to this, it is 6.022 times 10 to the 23rd power. This is known as Avogadro's number. Remember Amadeo Avogadro, the Italian scientist who first came up with the idea of molecules, named for him, although he of course was not the one to calculate it. It was calculated to be 6.022 times 10 to the 23rd for a specific reason. This is not just an arbitrary number. 6.022 times 10 to the 23rd is actually the number of carbon atoms, and that would be carbon 12 atoms. That would make up a mass of exactly 12 grams. But that you can just store away in the back of your head right now. Let's do something with this. Now, as chemists, what we do with the mole is we count. What do we count? Particles. Can you think of what we might be talking about when we call this mole the unit for counting particles? Yes, we might count molecules, or we might count the individual atoms inside the molecules. And it's very useful for chemists, because when you're counting atoms and molecules, the atoms and molecules in this Sharpie would number in the trillions of trillions, and we don't want to carry around bulky numbers with us all day, right? So we're going to count in moles. Let me give you an example problem. If you had 5.7 moles of popcorn kernels, I'm not only going to give you 5.7 dozen popcorn kernels, I'm going to give you 5.7 moles of popcorn kernels. How many popcorn kernels is that? If you multiplied by 6.022 times 10 to the 23rd, you would be correct. Here's how we do it. We take what we're given. It's always the correct place to start when we're doing conversions. We take the given and multiply it by a conversion factor. Now remember, that conversion factor has to be equal to 1, so whatever's on top here has to be equal to what's on the bottom, and we know that 1 mole is equal to 6.022 times 10 to the 23rd kernels. Just like 1 dozen would be equal to 12 kernels. or 1 gross would be equal to 144 kernels. And then we simply get our answer. Moles are canceled out, so for the number of kernels, we take 5.7 and multiply it by 6.022 times 10 to the 23rd. I'll let you multiply that yourself. If you had 0.234 moles of gold, AU, come back here with my gold jewelry, right? How many atoms of gold would that be? It's no different for kernels than it is for gold. Simply again multiply by 6.022 times 10 to the 23rd atoms over 1 mole. Can you do it backwards? If you had 12.04 times 10 to the 24 atoms of gold, could you convert that to moles of gold? Of course you could. We simply do the opposite. I'm going to divide this time by Avogadro's number, because whatever unit is there in the given, we want to write that on the bottom of the first conversion factor, and we want the goal units, moles, to be on the top. So what we were given at first cancels out, atoms cancels out. Now where do we put Avogadro's number? Well, we would be wrong if we said that 6.022 times 10 to the 23rd moles was equal to 1 atom, right? What is true is that 6.022 times 10 to the 23rd atoms would make up 1 mole. 1 mole is the quantities, that many atoms, or molecules or whatever particles you're talking about. Oops, bumped the camera. So you can multiply that out by yourself. And here's a final problem for you. If you had 9.20 times 10 to the 22nd molecules of water, how many moles of water would you have? I'm going to add the answers. I didn't calculate the answers yet. I'm actually going to do it right now.
But what if they just copy your answer?
Well, this is practice.
Oh.
They're expected to do the problem before they check the answers. If they don't do that, then they're not learning. Now, just because I'm going to write the answers down doesn't mean that if you got it wrong, you just change your answer. If you got it wrong, you go back and see what happened.